So today we have codechef uh, contest starter. So let's solve the contest we have. So here is the first problem statement we have. So I start from here. So here is the first question we have. So in this question, at ITA student have diverse sleep pattern and there is not a fixed duration for their daily sleep. Typical scientist recommendations suggest that the duration of a healthy sleep is 8 hours per day. So as you begin your journey as a programmer, you have tasked by the renowned programmer of ITA, Pavitra Pandey, with your first project. So your assignment is to write a program that makes as input the number of hours as a student sleep per day and judges how good their sleep schedule is. Specifically, if the student sleep for strictly less than 8, the programmer should output less. So basically, we have some number of test cases. Okay, some number of not. We will in every console we will get a single test cases. In that test cases, you will get an integer n as input, and they are asking you to print if n is less than 8. That means the student is going to sleep less than 8 hours, and in this case you have to print less. Okay, and else if n is equal to 8, in that case perfect, the sleep hour of this student is perfect. That's why you have to print perfect. Okay, and if we talk about the else case, if it is greater than 8, in that case you have to print that a student sleeps more than the perfect sleep. So that's it we have. So okay, so this is what we have to do in the first question. So let's run it. I think most probably it will work. Most probably क्या सही है. Okay, so let's move to the next question we have. So this is the next question we have. Okay, so in this problem what it is telling, Om Khangat, the person's name is Om Khangat, has come up with a problem that he thinks can be used in a codechef contest, and he submitted his proposal for review. Okay, so codechef review panel has n judges, each of whom will give Om's problem a point ranges in the region 1 and 10. Okay, denoting how good they think it is. Okay, so a problem is considered good if and only if every judge gives it a score that's strictly greater than 4. Okay, the problem is considered good. So you have to print either yes or no. If the problem is good, you have to print yes. And the definition of a good problem is that greater than 4. It's a score. Every judge gives it a score that's strictly greater than 4. 4 na? It's 4. Okay. So as you can see, the first test cases is not good. That's why the output is no. As you see the okay, so first take the number of test cases as input, then inside let's have a loop while t minus minus, and for each test cases we have an integer n as input, that is the number of judge, and then we will iterate a loop over I equal to 0, I less than n, and I plus plus, and we will get a integer x as input inside this loop. and if x is, अगर x का जो है वैल्यू क्या है, greater than 4 है, that means we have to simply increase the count value, and let's initialize that count by 0. so if count is equal to n, that means all the judges have positive feedback towards the question, and that means it is a good question. So you have to simply print yes in this case, and if this is not the case, then simply print no. Okay, so this is what the problem statement is telling. Okay, no, yes, no. So let's submit it. So as you can see, it worked. The second solution also worked. So let's move towards the third question we have, and let's see what it is. So 400 people have submitted right now the third question. Okay, little slow, my network is. Fourth, fifth, sixth, seventh, eighth. So here is the third question we have. In a cricket match, there are two teams, each comprising 11 players. The scorecard of the match lists the run scored and the wicket taken by each of these 22 players. Okay, so there is a cricket match, so each team has 11 players, so total player is 22, and the scorecard of the match lists the run scored and wicket taken by each of these 22 players. So determine man of the match. We access each player's performance point are awarded to a player as follows. Each run scored earns 1 point, every wicket taken earns 20 points. So the player with the highest total points is awarded the man of the match title. So you are given 22 players, so the players are numbered from, so find the man of the match. It is guaranteed that for all the points to this problem, the man of the match is unique. So it's guaranteed that the player man of the match, know if you trying to find the particular score of a player according to his run and wicket, then no two player classes for the score, highest score. So that means every time you will have one winner which you can decide. So decide which player is the winner. No, basically we have to, in each test cases we have to print two things. I denoting the index of the player with the maximum score. So basically the index of the player who is going to win this match, you have to print that. Okay, so what is the input format? In each test cases you have 22 lines, AIBI. Okay, so let's take the input in an integer t as input, that is the number of test cases we have, while t minus minus, and inside this loop we will simply have a for loop. For int I equal to 0, I equal to 1, I less than equal to 22, or I plus plus. Okay, so let's say initially the score value is 0. Okay, and let's say I and d is minus 1. Okay, so if SC1, let's say here you will have two things, the run and the wicket. So let's take the input run and another input, that is the number of wicket taken by this ith player. So let's say int SC1 is equal to run plus 20 times wicket. This is how the score is defined. Okay, so if SC1 is greater than, okay, SC, that simply means SC equal to SC1 and IND equal to I. So after running this for loop, you will automatically, your IND is going to store the player who is the man of the match, because IND is the player which is going to have a maximum point throughout the game. Okay, throughout the game, in the whole game the performance is best. Okay, so let's run it and see it works or not. (16:8). So let's put one thing, it can be the case that everyone has zero score. No, this can't be the case, that's why. Okay, so let's submit it. Okay, so let's move towards the next question we have. Oh, what error occurred? I think some network issue we have. No worry. So let's move toward the fourth question we have. So Arya the monkey is trapped inside a n cross m grid. So the grid has n rows numbered from 1 to n from top to bottom and m column numbered from 1 to m from left to right. The cell at the intersection of row I and column j is denoted by I comma j. Okay, so Arya want to escape the grid, of course, but first he needs information. Okay, so there is a grid m cross n size. So Arya want to escape the grid, of course, but first he needs information. So Arya is initially in the cell x0, y0 of a grid and can move to another cell by jumping to them. Arya's jump strength is L, meaning Arya can jump exactly L unit in any of the 4 direction. Okay, so L unit Arya can jump from any cell. So this is what you can see. So from A comma B, the position where Arya can move to is basically the 4 position where Arya can go. One is L unit upward, L unit, another is L unit leftward, rightward and downward. So how many distinct cell in the grid can Arya reach using 0 or more jump of this form? So basically they are asking you to find how many distinct cell that in which Arya can reach using 0 or more jumps. So Arya want to reach some cell, so they are asking you to find how many cells Arya can move in. So in each test cases you will have 10 की power 9 kinds of things. So here you can't write BFS, but you have to think BFS in this problem, because the constraint is so large that you can't write BFS, but you have to think BFS. So very simple thing we have to, so we have to think a bit in this question. So the constraint is nm will range from 0 to 10 की power 9. So I am just opening a whiteboard to explain this question. White BOARD board. Okay, 198. So see one thing, if this is the coordinate x naught comma y naught, so from here he can move L unit in this direction, in this direction, and in this direction, and in this direction, and from here onward he can move in this direction, in this direction, in this direction, and in this direction. So how many points he can move? So the number of points which is available in the left, number of points which is available in the right, and a number of points which is available in the up and in the down. So let's say D is the number of point downward, W is the upward, L is the leftward point, R is the rightward. So W plus D plus 1 time. Okay, so let's say if this is the case, so W is 1, D is 1, L is 1, and R is 1. So how many points is there? Basically this will be also a point, this will be also point, this will be also point, this will be also point. 3 3 6 3 9. So L plus R plus 1 into W plus D plus 1. That's what it is. So the question broke in a very optimal order of one solution. Okay, so in each test cases we will take the input T as the test cases, number of test cases, and then for each test cases let's run a loop. Okay, and inside this loop let's take the integer, how the test cases we will get n m x naught y naught and L. This is what the input format is, int n m x naught x y L. This is what we have the input. Scene, okay, scene scene n m x y L, x y L. Okay, so how can you now, how can we do that? Okay, so it's very simple. Let's find left. LF is left. So how many points will be in the left side? So number of points in the region 1 to y minus 1. Okay, 1 to y minus 1. So this is what the length we have. It's a 1 by 1. Okay, so in this case you have to do very simple thing, that is y minus 1 by L. This is what we have. And in the same way in the right side, how many points you will have? Okay, so you will have the number of points you will have in the right side is nothing but number of column is m. So let's do one thing. So 3 4 5, So m minus y by l. Okay, so in the same way, up, how many points there will be in the upward direction? So it's nothing but x minus 1 by l, and how many in the downside? So in the downside there will be very simple thing, that n minus x. So n minus x, that's it, we have by l, that's what we have. So C out, left plus right plus 1 up plus down plus 1. Okay, so here is one thing missing here. I have defined left as LF na, and right as RT, so that's it. So it may be some error because I have not tested the thing, it is actually the same expression or not. Okay, so we have to do the things in long. So let's LL, put LL everywhere. So let's convert everything into LL. So LL so here also LL, here also LL, and let's define LL long. Okay, so now I think it should work. So basically 126840, so correct. So let's submit it. So it worked. So let's move towards the next question. We have transformation cost. So Ayush is being interviewed for an executive role in the finance department of Aparoksha Triple IT Allahabad Annual Tech Fest. So Ayush is basically interviewed for an executive role in the finance department of Aparoksha Triple IT Allahabad's Annual Tech Fest. So Himanshu Sekhar, the interviewer, decided to test Ayush's mathematical skill with the following problem. Okay, so an integer is called good if when written in binary it doesn't contain 101 as the subsequence. 101 as a subsequence. Okay, for example 4 and 15 are good. So basically choose an integer x greater than 0 and add 2 to the power x to n. Cost of the operation is 2 to the power x. So Ayush's task is to find the minimum total cost needed to transform n into a good integer. So minimum cost. So the question is, we can understand this question in this manner. They are asking you that let's say there is an integer n. If you write the binary representation of this integer n, something like this, then it should not contain a subsequence 101. That means this number should not have a unset bit, 0 bit between two set bit, because if it will be there is a 0 which is present between 2 1, or that means this number is not a good. So basically we have to find the minimum cost to convert this n into a good integer. That's what the question are asking you to find. And to change this integer n into a good integer, the operation which you are allowed to perform is a very simple operation, that you can add an integer 2 की power x to n. So basically you can add, and if you add 2 की power x, then your cost get increased by 2 की power x. So what is the minimum total cost needed to transform n into a good integer? Okay, so you can convert this n into good array by adding some integer which will be the power of 2, and if you add 2 की power x, then your cost increased by 2 की power x. So they are asking you to find the minimum cost to convert this integer n into a good integer. So the basically each time if you add 2 की power x, you are going to increase the value of integer n, and another time again you add some 2 की power x, then again it get converted into some integer, some higher integer. So no matter in which order you are going to operate the operation, but the total cost will be the same. So we have to worry about the thing in a way that let's see what is the constraint we have. So you have 10 की power 5 test cases, and for each test case, so we don't need to worry about the order of operation. Basically each time you add, it's the value of n is going to increase. Each time you add, value of n is going to increase, and finally n will increase and become an integer n1, and in this n1 there will be no 0 bit, which is no 0 present between 2 1. So any number in which there is no 0 present between 1 can be, how you can represent that number will be simple. Every bit is 0 in that number, or in that number every bit is 1 in that number, or in that number. These are the two cases we have. And again one more thing is, these two numbers are good now, and one more thing, in this number only one set bit is present. So one of the three forms, in one of these three forms you have to increase this number n, and you have to reach you have to achieve one of this three form, then your number will become good. Okay, and if you reach n1 from n, and if n1 is good and greater than n, then the cost to reach n1 is basically n1 minus n, because this is the number which you are going to finally at a total add to this n to make it good. So basically we should iterate for all the good n1, all the good number, and for that number check the cost. So that's what we have. Okay, so any more restriction in the question? No restriction. So according to 3 2 1, it's already good. So 0 operation, 0 cost. 6 is to 6 to 8, तो 4 2 6 1 7 8 2 की power. So no worry, let's pick a has define ll long, has define ll define ll as long, and after that uh, let's have a integer long in value t as input, then while t minus minus, then let's take integer n as input, c in n. Okay, and let's iterate over a int. So number is going to belong in the region 2 to the power 30 now. So ll I equal to 0, I equal to 0, I less than equal to 31, I plus plus. Okay, so let's have a ll answer equal to 0, ll answer equal to 0. So here ll val equal to 1 ll left shift I, or ll val 1 equal to 1 ll val minus 1, val minus 1. Okay, so check if val is greater than equal to n, answer equal to minimum of answer comma val minus n, and in the similar manner if val 1 is greater than equal to n, answer बराबर minimum of answer comma val 1 minus n. Okay, so this is what we have, and after this simply c out answer indel. So as we see, this solution will work, I think, according to the things we have discussed. So it's not working. अरे यार, answer of. So let's initialize this answer value by 1e12. Okay, that's it. Now it will give correct answer. So 1 5, so 3 is already good now. 1 minus 1 0, not well minus n. So why it is not working? C out well for 6 we have to do 0 operation. Acha, we have missed one thing. We have missed one thing. That is basically we have not implemented the correct solution. There is one case which we are left with. Okay, that case is, let's iterate over this val 1 for int j equal to 0, j less than equal to I, or j plus plus. Okay, so do one thing, control C. So here we have to do one thing, val1 jar equal to 1 ll, here is less than I, 1 ll j. That's what we have done. Let's see, because some bunch of 1 are placed, and in the left of that ones there is 0, and in the right also 0. So 1 5 4 to 6. Val1, here have one more mistake here, that is val1. Zero to 5929. So it's now working, but it should not give TLE. Let's see. Okay, so as you can see the solution worked. So let's move towards the next question we have. Okay, so matrix modulo, this is the another problem we have. And here in this problem, matrix modulo n cross n matrix B is called K strange. So n cross n matrix B, there is a matrix B which is n cross n in size, is called K strange if it satisfies the following condition: each integer from 1 to n square appears exactly once in B. Okay, so each integer in this matrix B present only once, then it is called K strange. So there is some condition for the matrix being the K strange. Okay, that is so the for matrix being the K strange, there is some condition that each integer from 1 to n square appears exactly once in B, and if every element of B is reduced modulo K, the resulting matrix is symmetric. So symmetric matrix, symmetric, so symmetric, and the okay, so as you can see the symmetricity means Bij is equal to Bji, that is the symmetricity means. Okay, so that's what we have. Okay, K strange matrix is what? First thing is 1 to n square, every element is present exactly once in that matrix, and after that if it is K strange, that means if we take the mod of every element present in the matrix by K, then the resulting matrix will be a symmetric matrix. So for example 4 3 1 2 is both 1 strange, 2 strange, and 3 strange. Okay, so the given matrix has 3 strange value, 1 2 and 3. So meanwhile you already know. So let mn be the largest integer for which there exists mn strange n cross n matrix. So Sahil has with him an n cross n matrix A, but some of its elements are missing. which elements of A is neither an integer between is either an integer between 1 to n square or 0. So find the number of ways to fill in the zeros with integers so that the resulting matrix Mn is strange. Okay, and what is this n value? So n is value 500. So we can write a solution of n square. Okay, so you can write a solution of n square. So basically the given matrix have some element which is 0, and at those 0 places you have to fill with some integer, and they are asking you to find they are asking you to find the number of ways to fill with 0 so that the resulting matrix Mn is strange. So here is K strange. Okay, so let Mn be the largest integer for which there exists an Mn strange n cross n matrix. Let Mn be the largest number for which there exists. बहुत टफ बुझा रहा है भाई. अजीब लग रहा है सवाल. Mat mod. So Mn be the largest integer for which there exists. Context देखिए. Let Mn be the largest integer for which there exists Mn strange n cross n matrix. Sahil has with n cross n matrix A, but some of the elements are missing. So find the number of ways fill in the zeros with integers so that the resulting matrix is Mn strange. Number of ways in which you can fill. So n strange means if you take it modulo with 1 it will be a strange, modulo with 2 it will be a strange. So if you vary k value from 0 to n and 1 to n, and for each k value it is satisfying the condition, that means it is a mn strange matrix. So basically we have to make this matrix a mn strange. So this matrix want to be the mn strange. So let's talk how we can approach this problem. It's basically we can write the order of number of cell complexity of solution. ठीक है? Okay, so this is what you can write, the solution which you can write. Okay, one thing is clear, that you want to count number of ways, so that this matrix is a strange for all value k belonging to 1 to n. This is the second thing we have. And in this matrix some number are fixed and some are not fixed. So let's say if this is the diagonal of this matrix, this is the diagonal cell, so this cell should be equal to this cell, value in this cell should be equal to this cell, and the value in this cell should be equal to this cell. So this is what you have, how the cell value is going to be to work. This is how the cell value is going to work. So it may be the case at the both places there will be 0. Okay, at both places there will be 0, at both places there will be 0. Okay, okay. So if or it may be the case that one of the value is 0 and another is not 0, that means you have pairing. If these two values are 0, then you have some number of edge which you can select, some number of edge. Okay, this is the number of edge you can select. Okay, नहीं अभी आबै छु. Okay, so we have a number from 1 to n square. For k equal to 1, every number can be equal to every number. So basically some number are fixed, so basically you can tell that every number is connected. Okay, every number is connected, they are giving the. So tell me one thing, that a number x can be put it just diagonally opposite side towards a number y if and only if x modulo 1 is equal to y modulo 1, x modulo 2 is equal to y modulo 2, so on, x modulo n is equal to y modulo n. Okay, so if you talk about your graph, so in this way if you say that my number x and y is connected, if you say that my number x and y is connected, that means it should, this age is only valid if x modulo k is equal to y modulo k for all k belonging to 1 to n. This is the first thing we have. So let's say anyhow you have finded the graph. So in that case you will have some number of connected component. You will have some number of connected component, and each connected component had some size. So basically every connected component will have some size. Every connected component will have some size. So every size should be even, because every size should be even. No, not really every size should be even. So some components will have odd size, some has even size. So some component will have odd size and some has even size. So from odd sizes component, pick one odd which is not originally present in the given grid, and these odd you should place at the diagonal. And after that, what should happen? After that, what should happen? Your diagonal should be get filled. Okay, your diagonal should be get filled. So the main challenge is how can you can find this connectivity. This is the main challenge you have. How can you find this connectivity in an optimal way? Okay, can you write a solution of NQ? You can't write a solution of 125 into 10 to the power 6. It's not valid. If you can write NQ solution, then definitely we can have that, but we can't really write NQ solution. I think there is a mathematical equation which solves this problem. X modulo k is equal to y modulo k. How can you find this solution? How can you find the solution? How can you find the solution to this problem? Okay, so let's find the solution. So one thing I want to discuss, that let's say you have a graph in this. Let's find the age which is not a valid age. Let's say this age is not a valid age, that x can't be in front of anything. Let's say x can't be in front of y. Okay, cost. Ravi has a, so let's solve this problem of tree. I think we can do the tree section. So Ravi has a tree with n nodes with its root being 1 and the ith node of this tree has pi points. So there is a rooted tree with n nodes and ith node in this tree has pi points. Ravi is initially standing on node 1 of this tree and he do like to visit several nodes of the tree and collect points. Node 1 of this. Ravi is initially standing on the node 1 of the tree. He do like to visit several nodes of this tree and collect points. To do this, he can move through the edges of the. He do like to visit several nodes of this tree and collect points. To do this, he can move through the edges of the tree. That is, if Ravi is standing on U, he can pick a neighbor of U and move to it. So this can be done, however, many times he likes. So it is allowed to visit nodes multiple times. Okay, so Ravi has a score S which initially equals to P1. The first time that Ravi visits a vertex U, he must add Pu to his score. Note that node 1 is considered visited since Ravi starts there. Ravi objective is to maximize S. Okay, so Ravi, however, has been cursed. Whenever he moves from a vertex U to its child V, the points value of every node in the subtree of V decreased by 1. Okay, so Ravi, however, has been cursed whenever he moves from a vertex U to its child V, the points value of every node in the subtree of V decreased by 1. Okay, so this decrease happens before Ravi reaches V. Okay. So Malay decided to help Ravi a little and can lift Ravi's curse for exactly one node. Mala decided to help Ravi a little and can lift Ravi's curse for exactly one node. That is, Ravi can choose a single node X and Mala will ensure that Ravi curse doesn't activate when entering node X from its parent. So Ravi wants to maximize his score but doesn't know how best to make use of his one time use boon. अच्छा, अगर रवि exactly एक नोड चुन सकता है, a single node X, and Malay will ensure that Ravi curse doesn't activate when entering the node X from its parent, meaning the values within the subtree of X will be unchanged. अच्छा, जब वो पेरेंट से उस नोड पे जाएगा तो उस समय जो है नहीं घटेगा. Okay. So Ravi wants to maximize his score but doesn't know how best to make use of his one-time use boon. So turns to you for help. So can you tell Ravi what is the maximum possible score if he chooses to lift the curse for node X? अच्छा, अच्छा. Let's look at the what happens when the curse is relaxed for node 3. Initially, Ravi starts. First, Ravi will move to node 2, which is child of 1. The curse activate and everything. Okay, so let's see this one of the graph: 1 to 3, 1 to 2, 2 to 4, 3 to 5, 3 to 6. So let's draw this graph. So if you draw this graph, the graph seems like this. Okay, so let's draw the graph. 1 say 2, 1 say 3. So we have a path from you can move from 1 to 2 and 1 to 3 from 1, and similarly 4 from 2, similarly 4 from 2, and similarly 3 to 5, 3 to 6. Okay, like this. So he can go from here, no curse. If he will apply curse on node 3, then there will be no problem. Okay, so let's put one more thing: 4 3, 3 to 6, 3 to 5, 3 to 6. Okay, 3 3 6. Okay, 4 3 2 3 3, 4 3 2 3 3 minus 5, 4 3 3 2 3 4 3 2 3 3, 4 3 2 3 3 minus 5. This is what we have. Okay, so 4 3 2. Okay, 3 3, and here is the minus 5. Okay, at 6 there will be minus 5. So if you apply at 3, so I am just finding for one test cases, otherwise we can solve it. You can see, if we apply at 2 3 4 5 6, if you apply at 2, then a score will be 11. So for your score is 4 plus 2 8 from here, plus 1 9, 9 1 10, 10, 4 2 6 2 8, 4 2 6 2 8. Okay, 4 3 7, 4 3 7, 2 9, 1 10, 1 11. One more thing, that So, so here is that Ravi don't need to visit every vertex of the tree if only wants to maximize his score. So he will go somewhere if really it will benefit him. Otherwise, why he will go? में दिक्कत आ गया नहीं. So every node can lie in the two case. Every node can lie in the two cases. One case is it is a part of a subtree. It is a part of a subtree whose root, the root of that subtree is basically the node where he is going to operate. Okay, this is what the case we have. Okay. क्या यार कैसे करें? So let's say for every test cases, take the input, and for each test cases, let's call a function solve. Okay, return 0. Then inside this solve function, we have an integer n as input, c in n. Okay, then we have vector of int adj n plus 1. Then we have vector of int, that is p of n plus 1. then we have, okay, for int I equal to 1, I is less than equal to n and I plus plus c in p of I. That's it we have. Then let's run a loop. Int I equal to 0, I less than n minus 1, I plus plus. So int u comma v, c in u, c in v, and then we have adj of u dot push back v and adj of v dot push back u. Okay, so we have the graph ready. So the graph is ready. So I was telling one thing. Let's say this is the tree, this is the node 1, and somewhere it is node 2, like this. This is what we have. So if you apply operation at this place, okay, if you apply operation at this place, then you want to find the if you apply operation at this place, okay, then maximum score you can achieve from these places without operating, without not operating. So dp of ch1, ch2, ch3, dp of ch1 not operating, dp of ch2 not operating. So summation of this value is going to be your answer. And let's talk about in this region. So the operation you are doing for the benefit now. Obviously you are doing operation for the benefit. So what is the maximum score you can achieve? What is the maximum score you can achieve by operating at this point 1, 2, node 2? That is basically dp of 2 op. And what is the operation, what is the score you can achieve by operating, by not operating at this ch3, ch4, ch5 like this? So dp of ch4, ch5, ch6 not operating. So there will be summation of this value. From this value decrease the maximum score you can achieve by not operating at this point, no op, minus dp of 2 nop. And if we consider more, so basically dp of 1 no op minus dp of 2 no op plus dp of 2 op. So basically one more thing we have to see here. So if you calculated this dp table previously, let's say you have calculated this dp table, so you will come at this node for some benefit, huh? And that benefit is from this node you have somehow reached this node to apply operation no op. I will not apply op. So there will be some cost after applying this operation, some benefit. Okay. First thing, it should be greater than 0. Then we will these no op value, sum of these no op value, sum of these no op value. पहले तो ये ग्रेटर देन 0 होना चाहिए, ठीक है, पहले तो ये ग्रेटर देन 0 होना चाहिए, तभी हम यहाँ पे आएंगे। और यहाँ पर आएंगे भाई, और फिर ये सब चीज़ का वैल्यू तो जोड़ना ही पड़ेगा अपने को, ठीक है। हाँ ठीक है, एक बार so we have to basically apply rerouting concept after calculating the dp table. Let's say dfs of vector of int dp n plus 1 comma vector of int 2 comma minus 1, let's say. Okay, so let's have a dfs of 1 comma minus 1 comma, here you can't apply operation, basically you will enter without applying operation at this point, so 0, no op. So how can you implement that? dp of 1 0 and give him dp table. So int dfs int v comma int pre comma int op no op nope, or vector of int and dp. Okay, so here will be two cases, NOP is equal to 0, or else it will be 1. So these are the two cases we have. dp of 1 equal to dfs of 1, -1, 1, dp। ठीक है, दो लोग बना दिया भाई, इसको एक लोग बना दिया भाई। ठीक है, NOP इक्वल टू 0, अबे यार बहुत क्रूशियल है, कोई क्लियरिटी नहीं इम्प्लीमेंट कर रहा है।